Hello everyone, this is for section 10.6 for pre-calc. It's dealing with polar coordinates, and the difference with polar coordinates is how the coordinate is given. It's given as r theta. So for example, you could have 345 degrees. There's nothing that says it has to be written in radians. You could have -5 11 pi over 6. Okay? It's just r theta. There's nothing, like I said, that says when you write something in polar coordinates that it has to be in radians. But as you can see, the unit circle I've drawn on here is in radians, so I'll be referencing stuff in radians. There we go. I don't know why I was holding off on the word, but there you have it. Now, the book is going to instruct you that you do the radius first. So giving this one right here, it says walk out. So I guess I should say, because it's negative, this is considered a positive direction, this is considered a negative, as far as what direction you're facing. Now, I'll clarify that in just a second here. It's because I'm facing the direction as 0, that's why this is positive and that was negative. But I'll give you some advice first. The book is going to say that you walk the length first. So starting here, 1, 2, 3, 4, 5, so you're here, and then spin 11 pi over 6. Now, this is why I think this is perhaps a bad way to go following the book's advice. From here, you have to rotate 11 pi over 6. So you actually would rotate all the way around 11 pi over 6, not facing 11 pi over 6. So your actual coordinate is right there. And I find that confusing. And I think you might too. Now let me show you a different way to do it that I think is cleaner. Face the angle. So look this direction, face this direction, and then go backwards 5 units. So you go 1, 2, 3, 4, 5, and there's your coordinate. Okay? I think it's easier to face the angle and then walk the distance. So for this one, 345. So I'm going to face 45 degrees, which is pi over 4, and then walk out 3 rings. And you're done. Do it whichever way you like. I think it's easier to face the angle first. So let me do that 345 the way the book is going to say it. The book is going to say walk out 3 units, 1, 2, 3, and then rotate 45 degrees so your finishing point is right there. It's not so bad when your distance was positive, but when it's negative, I think it particularly makes it bad. Let me give you another negative. How about -6 and 2 pi over 3? The book's going to say back up 6 units. So I'm going to back up 6 units. 1, 2, 3, 4, 5, 6. And then from there, from this point here, you need to rotate 2 pi over 3. So 2 pi over 3 is going to take you to here. Nope. I did the wrong amount. See, that's why I think it's difficult to do. There, my eyes are kind of going crazy. So 6. I lost track of where I was rotating. Right there. There it is. So my arc was in the wrong spot. Let me trace that arc a little cleaner. So rotate out 6 units, 2 pi over 3 from this starting point, and this would be your final answer. Whereas if you follow my advice by doing the angle first, I'm going to face 2 pi over 3, so I'm facing this direction. And from that direction, then I'm going to go backwards 1, 2, 3, 4, 5, 6. So you see, you end in the same spot. I just think it's a whole lot easier to do. Okay, because you're facing the angles you already know, rather than trying to figure out, okay, how much do I rotate the 2 pi over 3? Well, where is that? Okay. The next piece I need to show you is how to translate from polar to Cartesian or rectangular coordinates. So let's use the example I gave you, 3 pi over 4. So you're going to face 45 degrees, so you're facing this direction, and then walk out 3 units, 1, 2, 3. And so there would be your coordinate. Now what you're trying to do is figure out what is this coordinate in rectangular coordinates, so in your regular XY coordinate. Well, the idea is your X value is how far over you are, and your Y value is how far up you are. Well, if we just draw a triangle here, so we're 3 units out and at 45 degrees. If you draw a triangle here, this leg is your x, that leg is your y, and this angle in there is pi over 4. Well, if you want the adjacent, that's cosine. Cosine of pi over 4 equals your x value over 3. Multiply both sides by 3, and I have 3 cosine pi over 4 is x. And then we know 3 cosine of pi over 4 is square root of 2 over 2. So I have 3 square roots of 2 over 2. To get this side, that's your opposite and hypotenuse, so that's sine. So the sine of 45 degrees, or pi over 4, is equal to your opposite side over 3. Multiply the 3. And that's square root of 2 over 2. Whoops. 3 square roots of 2 over 2. That's times. So it's just 3 square roots of 2 over 2. Now, what you should notice is this is your y value, and this is your x value. And I'm going to leave it in that format for a second. So the coordinate is 3 cosine of the angle. That's a 4. 3 sine of the angle. So that's your x, that's your y. So generically, what that's telling you is it's your radius, the r coordinate, cosine of whatever the angle is, radius sine of whatever the angle is. So if I asked you to convert, I don't know, 2 and pi over 6, all you have to do is go to cosine pi over 6 to sine pi over 6. You don't have to redraw the triangle every time because this is the conversion from polar to rectangular. Okay? So that should do it.